Hello, and welcome to the Solutions Testing Laboratory. Okay, so we're going to have a look at problem number 31 out of your course pack. It's part of exercise set 7.7 on page 533. And this question asks us to use the associative and commutative laws in combination to create equivalent expressions to this expression here. Okay, so before we do that, I just want to talk a little bit about what these laws are and what they mean. So let's look at the associative law first. And the associative law is about groupings or associations. What it's saying is that, in a nutshell, when you're looking at an expression like this that involves addition, the associative law basically states that 5 plus 2 plus 3 can be rewritten as 5 plus 2 plus 3. Okay, so I have not changed the order. It's still 5 plus 2 plus 3, 5 plus 2 plus 3, but I'm changing what's inside the brackets or what's grouped or associated together. So I've got 5 plus 2 here inside the bracket, where here I have 2 plus 3 together, and the 5's outside the bracket. So that's the sort of associative law in a nutshell. So let's look at how that might be applied to our question. So if we think about that idea of changing the groupings or what's inside the bracket, what's outside the bracket, then couldn't we quite easily rewrite our expression as 5 plus W, 5 plus V plus W, right? That would be an equivalent expression. This expression would have the same meaning as this expression. It's equivalent. So there's our first equivalent expression using the associative law. Now, the commutative law is a little bit different. It's about order. And what the commutative law says is that 5 plus 3 is the same as 3 plus 5. I can change the order without changing the meaning. 5 plus 3 is 8, and 3 plus 5 is also 8. So it allows me to change the order, which can be helpful when I'm trying to solve equations, which we'll get to a little later. So coming back to our original expression, our problem number 31 here, let's use the commutative law to create a quick and simple equivalent expression. We'll just change the order of the two variables inside the bracket. Right. So we had V plus W here, now we have W plus V, an equivalent expression. Now, we can also think about the bracket, V plus W, that whole bracket. We can think of that like a term, an object, a piece of the expression. And so we could change the order in which the 5 and the bracket appear and change the expression to be the bracket plus 5. So we could change our expression to be a V plus W plus 5. Right? See how I've used the commutative law to change the order. I had 5 plus bracket. Now I have bracket plus 5. Another equivalent expression. Okay, so I've got 3 equivalent expressions again. Now let's look at our newest equivalent expression. That was V plus W plus 5. Now how about I use the associative law again now and change the grouping. So I could rewrite that as V plus W plus 5. All right, so I've just grouped W plus 5 in the bracket now, and I left the V outside, whereas in the this expression, the 5 was outside the bracket. So here we have another equivalent expression. Now I'll do one more, but I think you can kind of see that there are many different equivalent expressions that you could generate using the associative and commutative law. But let's just do one more, an easy one. We've got v plus w plus 5 in the bracket. We simply use the commutative law to change the order of the two terms inside the bracket. So we could say then that v plus 5 plus w in a bracket is an equivalent expression to this expression, which is an equivalent expression to this expression, our original question. So we have now a fifth equivalent expression. And I could certainly continue, but I think you got the idea.